Stoichiometry calculations with mass. Unlike volume, particles, and moles of a material, they are independent, the ones we just talked about. Volume, particles, and moles are independent of the type of material present. However, the mass of a material is specific to each substance and therefore different. Here's a couple examples. Oxygen gas and hydrogen gas. We take a mole of each one. Each one has 22.4 liters, that's the volume. Each one has the same number of molecules, that's Avogadro's number there. However, look at the mass. The mass is different. And where do you get the mass from? Periodic table. You convert atomic mass units into grams by just replacing AMU with G. Depending on the units, there are many ways to interpret a balanced equation. So here's our balanced equation. 2H2 plus 1O2 yields 2 H2Os. We can deal with it in molecules. 2 molecules of H2 plus 1 molecule of O2 is 2 molecules of H2O. Or we can use moles, abbreviated MOL. Or we can use liters, okay, a volume measurement. Or we can use grams. All of those come from this one balanced equation. How many grams of hydrogen gas would need to react with 3.4 moles of oxygen gas? As always, we start with a balanced equation, and in this case we're going to go from moles of oxygen, that's our given up here, right there, translate that to moles of hydrogen, and then find out how many grams of hydrogen gas we have. So we start 3.4 moles of oxygen, and we note that we have 2 moles of hydrogen for every 1 mole of oxygen, 1. We now have to multiply that by 1 mole of hydrogen is equal to 2 grams. Okay, because the atomic mass of hydrogen is 1. There are 2 of them, so we get 2 grams. Then we multiply through, and we cancel a lot of stuff out. And we're left with grams of hydrogen, 13.6 grams of hydrogen. Charts are cool. Let's say we start with the mass of substance A. We can use the ratio of the coefficients of A and B. So see here, that's mass A, and little a is the coefficient, the number in front of it. So that's the reactant here, and in the product, B is the coefficient, capital B is what the substance is. We start over here. We're given grams of substance A. We use the molar mass of A, which we get from the periodic table where it shows the AMU, and replace AMU with little g for grams. That tells us how many moles of substance A we have. We then use the coefficients, here that's the little a and the little b, from the balanced equation, and we find how many moles of substance B we have. Then we find the molar mass of B from the periodic table, and we have the grams of substance B. Calculate the mass of ammonia produced by the reaction of 5.4 grams of hydrogen gas, right there, with an excess of nitrogen. Excess of nitrogen means there's plenty of nitrogen there for all of the hydrogen gas to react. We will talk about that a little later in this unit, so don't worry about that now. So go ahead and work this on your own. When you're ready, please come back. Pause the video. Come back when you're done, and we'll pull out the answer tab. Okay, let's see. Hopefully you got it, but now let's go through it. Strategize. We're going to start with how many grams of hydrogen we're given, convert that to moles of hydrogen using the molar mass, convert that to moles of ammonia using the coefficients in the balanced chemical equation, and then convert that to how many grams of ammonia, once again the molar mass. So here's our grams of hydrogen. Here's our molar mass of hydrogen, right? 2 grams per 1 mole. Then you look at the balanced equation. There's 2 moles of ammonia for 3 moles of hydrogen. And then finally, back to the periodic table, the molar mass of ammonia, which is 17 grams there. Multiply all those guys out, and you get 31 grams of ammonia.